There will be times when we want to find the domain and range graphically. The way we do this is using the following set of steps. To find the domain graphically, what we're going to do is take a look at the graph and determine the farthest left, or in other words, the minimum x that the function reaches. Then we're going to determine the farthest right, or the maximum x that the function reaches. And finally, we're going to take a look to see if there are any values of x which the graph skips. To do the range, we do almost the same thing. We determine the farthest down, or in other words, the minimum y that the function reaches. And then we go and we determine the farthest up, or the maximum y that the function reaches. And then lastly, we look to see if there are any y values that the graph skips. Let's take a look at a couple of examples. So first of all, letter A. I want to find the domain and range graphically, and my function is the quantity ax divided by the quantity 2x minus 1. So I went on my calculator and I graphed this particular function. Don't forget that when you go to put this in your calculator, you need to put 8x in the numerator in a set of parentheses, and the 2x minus 1 in the denominator in a set of parentheses. So when I graph it, and I expect that you would probably want to sit down and make sure that you can get the same graph, we get something that looks like the graph that you see on the screen and on your paper. You'll notice when you look at the graph that I changed the window. If you actually use a negative 10 to 10 window, the graph won't look quite the same. I actually did negative 3 to 3 in the x's, and I believe negative 10 to 10 in the y's. So now if I look at the graph and I follow my steps, to get the domain, I look and I say to myself, how far left does this graph go? Well, we know it runs off the screen, so it goes left to negative infinity, and it goes right all the way to infinity. So I go left to negative infinity, right to positive infinity, and then I look to see, are there any values it skips? And of course, from doing the algebraic technique that we did in the previous set of examples, we know that it's going to skip when x is 1/2, because that's when the denominator is undefined. So what happens is the domain is broken into two pieces. The first piece goes from negative infinity on the left up to 1/2 on the right. The second piece starts at 1/2 on its left and then goes to infinity on the right. And I wrote this in interval notation. And remember, the way we do interval notation is we go left endpoint of the interval, comma, right endpoint of the interval. Infinity always gets a parenthesis, so the negative infinity will have a parenthesis. We can't actually reach the 1/2, so we use the parenthesis on the right side. And the same with the second piece. We start at 1/2, comma, infinity, parentheses on both. We can't reach infinity. We also cannot actually equal 1/2. So let's now take a look at the range. So we say, how far down does the graph go? And again, it looks like it goes to negative infinity. Looks like it goes to positive infinity in the top. And then we have to play around a little bit. And you might have to look at the calculator. You might have to do some computations, play with your window. But the value that this is skipping, and we'll learn more about y later on in the course, the value this one's skipping is when y is 4. So it's going to, again, be two pieces. Notice that we have the break in the graph. So our range, the first piece, the bottom piece, is going to go from negative infinity on the bottom up to 4 at the top, not including either one, so the parentheses. And then the second piece is going to pick back up at 4, go to infinity, but not touch that 4. So 4 infinity with parentheses on both. Let's take a look at a little more challenging example on B. B of x is the quantity x plus 1 divided by the quantity x squared plus 3x minus 10. Now when I go to look at the domain, and remember, this is probably one I quite frankly wouldn't probably do completely the graph. I'd probably do the algebra, set the denominator equal to 0 and factor it. And I would learn, of course, that that the denominator is going to be 0 when x is negative 5 or when x is positive 2. And you'll notice when I look at this, I have 3 pieces. So there's kind of 3 things I'm going to have to be concerned about with the domain. So if I take a look at the first piece, the one to the far left, it's going all the way to the left, so it's going to negative infinity, and it's going to stop off at 5. And if you take a look at the graph that I graphed, you can actually see that in the graph. Then the second piece is going to pick up where that left off, -5, and go over to where it ends, where that second undefined location is, and that's at 2. Then the last piece is going to go from 2 to infinity. Since we know we cannot have x be -5 or +2, we'll have parentheses on all of the parts. Again, remember the infinity pieces must have the parentheses. Now the range. The range is kind of interesting here because if we look at this, it's fairly obvious that the graph is indicating to us that it goes down to -infinity and up to +infinity. But we have these pieces that have a break. So you'll notice that the piece on the far left and the piece on the far right appear to not touch the x-axis. They appear to not touch where y is 0. But notice that the piece in the middle actually does. The piece in the middle covers all values of y. And so based upon that, all of our y's will actually be used for our range. So our range is going to go from -infinity all the way up to +infinity. Let's now move on to c. Notice we've gone from a fraction to just a square root this time. So in c of x, we have the square root of 3 minus 4x. Now if I graph this, you'll notice I get what I think of as the typical square root function that looks like half of a parabola laid on its side. And again, later in the course, we'll see that even more. But notice when I graph it, if I look at the domain, it looks like it goes left forever, right? Remember, it doesn't just stop here. It would keep going if I changed my window. And then it looks like it goes right to whatever this value is. And remember, when we found the domain algebraically, we learned that what we would do is take what's under the radical, the radicand, and set it greater than or equal to 0. And if I set that greater than or equal to 0, that's when I manage to get that x is less than or equal to 3/4. I have to be a little careful with the inequality and the negative. So this is actually kind of stopping right here at 3/4. Notice on this one I could actually equal 3/4. If I substituted 3/4 in for x, I'd get the square root of 0, which is a legal value. And so I can take the square root of 0, so I go right up to 3/4. That's not uncommon with square roots, that we actually have an equality piece, as long as our square root doesn't appear in the denominator, as long as there's not something else going on in the function. So we go left to -infinity, right to 3/4. Again, on the infinity side, we use the parenthesis. The 3/4 we can equal, so we use a square bracket. Now our range. Our range appears to have its low point on the x-axis, so that's when y is 0, and it will keep going up. It actually goes up and up and up forever. It doesn't do it all that rapidly, but this graph would keep increasing. So if I look at my bottom location at 0, my top would be infinity, parenthesis on the infinity. We do actually physically get the number 0. That's when we substitute in that 3/4. And so we actually can equal, the range has the equality at 0. Letter D. D of x is 5 divided by the square root of x minus 7. Now notice we have the square root, but we also have the fraction. And we're going to talk a little bit about this. I'm going to make a little minor change here. I set this up so that I could talk about it in this way. If I just address the square root piece, just like the last example, x could be 7. But notice here it's in the denominator, so x can't be 7, otherwise I get a 0 in the denominator. So let's take a look at our domain, and we'll make our little quick adjustment here. So when we look at our domain, how far left does it go? Well, it's stopping right here at 7. We got the 7 issue going. And then how far right? Infinity. Well, we equal infinity on the right, right? But we can't, or we get out to infinity, but we can't equal it, so we actually have the parenthesis. On the left, on the 7, I put the bracket, but let's think about that, right? I started off with that because of the square root. But notice, can I actually equal 7? Hopefully you're saying no. And so what we actually would do is we would not have the bracket. Instead, we would, of course, have to have the parenthesis. So make sure that you go through and you put the parenthesis on your particular example. Now let's take a look at the range. The range is a little bit tougher in the diagram that I've drawn here because when we look at the range, it's hard to tell that it goes all the way down to 0. If you expanded your window out, you would see it's going down to 0. Another way to think about this is if we let x get bigger, 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 the denominator is going to get bigger, 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 even with the square root. And so I'm going to take the number 5 and divide it by something that gets larger and larger and larger and larger, which would tell me that my denominator is going to go to 0. Or not the denominator, I should say the fraction is going to go to 0, because 5 divided by a larger number would end up being 0. Or going to 0. Lastly, let's look at e. E is r of t is 30 divided by 1 plus 5 multiplied by 0.2 to the t. So if I put this one in my calculator, again, remember the entire denominator needs to be in a set of parentheses, I get this kind of neat looking function. If I look at the domain, it looks like it's going left forever and right forever, so the domain's all real numbers, which remember I could write as negative infinity to infinity. This time I just happen to write all real numbers. Now the range, again, I want to take a look at, because when I ask students, usually they say, oh, it looks like it's going up, so it's going, it looks like the bottom goes to 0 and the top goes to infinity. But is that truly the case of what's going on? If I really take a look at this, is it really that particular case? Now, if I went to my calculator and I played around with this piece, I think you would actually find that what's going on here is this is not actually going to infinity. And if I take a little look at the function here, let's kind of guess what it's going to be without trying to take a look at the graph. The 30 and the 1 doesn't matter what the t value is, those are going to be 30 and 1. If I take 0.2 and I raise it to larger and larger powers, so if I take 0.2 to the 0, well, that's going to give me 1. If I did 0.2 to the 1, that gives me 0.2. If I take 0.2 and I square it, that gives me 0.04. It doesn't take too many of those to realize that this 0.2 to the t for larger and larger t's is going to go to 0. So this piece is going to go to 0. So I'm going to have 30 over something that's going to 1 plus 0. So it appears this is going to go to 30. So instead of my range going to infinity, my range, let's fix that, is going to go from 0 up to 30. Now let's think about it. Will we ever get down to 0? Well, the graph looks like it, but technically we never will. Eventually your calculator's decimal point issue will make it look like 0, but we actually won't get there. So I'm going to use a parenthesis, and then I'm actually never technically going to get to 30, even though it does look like it reaches it, but we're going to get ever so close. Eventually your calculator will round it, but we really, really will never actually get there. Let me, while I'm doing this, just before I turn this off, let's fix this. What did we say this was going to be for our range? Oops, excuse me, it wasn't the range, it was the domain. What did we say it was going to be? 7, right, to infinity? But remember the change we wanted to make was we wanted the 7 to be in parentheses.